All right, so the amount of sugar in Krispy Kreme is 10 grams. Many people feel that cereal is healthier. So this data table has the amount of sugar in 19 randomly sampled types of sugar. So is there enough evidence to show that the mean amount of sugar in children's cereal is more than in a glazed donut? Test at the 5% level. So our null hypothesis is that mu equals 10. The alternative is that mu is bigger than 10. Our alpha level's 5%. Our sample size is only 19, so that's a small sample. So if it's a small sample, then that means we have to have normality in the parent population, or at least we have to hope that we have a normal distribution of the parent, but we don't have that up here, so we have to check our sample. So we're going to go to our sample and we're going to graph it. And so we're going to go zoom 9, and that's relatively mound-shaped. It's got a little bit of left skew to it, but it's relatively mound-shaped, which is good for us. And then we're going to do a box and whisker plot. And again, zoom 9. And we've got this low outlier, so that outlier could affect our decision. So if our sample mean comes out pretty close to our population mean, then we're going to not reject the null, but that decision might be influenced by that outlier. So we need to keep that in mind when we make our decision. So let's see, let's do a normal probability plot and see if that comes out to be normally distributed. And it's got that bend in it, right? So it's telling us that it's slightly skewed, but it's not so dramatically non-normal that I can't continue with the problem. Okay, so we have to assume that we have an independent simple random sample because the problem doesn't tell us that it is. Our sample size is clearly smaller than 10% of all of the sugared cereals we could have sampled. The normal probability plot is okay. It's not perfect. There is an outlier, but we know we're going to have to take that into consideration when we make our decision. So our sample average is 11.15. Our standard deviation of the sample was 2.95. So stat calc, one of our stats on our sample. So there's our standard deviation, 2.9488. And there's our sample mean. And then we're going to do a t-test. So here's our t formula, right? What we observed minus what we expected divided by the standard error. So our t-score turns out to be approximately 1.7. We can go stat, test. This is a t-test. Mean is 10, so we'll just do it from the data itself. So the null is 10. Our data is in list 1. We want to be bigger than the null, so let's calculate it out, or we'll draw it out. And we get out here at about 1.7. The p-value is 0.0521. We're testing at an alpha level of 5%. So the probability that our t-score is as big as 1.7 is approximately 0.0521. So therefore, we are not going to reject the null because our p-value is not quite small enough. But now we need to stop and think for a second. We're not going to reject the null because our mean was fairly close to this 10. But remember, it is entirely possible that that decision is being influenced by the small outlier. So remember that 3 was an unusual number in comparison to everything else. So we can't throw that out, but in our report, we could suggest that perhaps they pull a new sample because our decision to not reject the null is probably being affected by that one particularly low score. So we can't throw it out, but we can note that it was an influential point. If we did throw it out, which I'm not going to suggest that we do, but notice if we go stat edit and we take it out and then rerun the numbers and go stat test t-test, and again I'll just calculate it. See, now without that one score, we're 3 standard deviations away because our new sample means 11.6, right? That sample mean is now bigger because it's not being yanked to the left by that one score. So now we would have rejected the null with a lot of evidence. So do you see the difference that that one score made? Now, we can't just throw out that one observation and make our decision now based on this, but we could suggest that whoever the researcher is might want to pull another sample because of that influential score, or to at least reanalyze the data with the understanding that there is some evidence that we do have serial that has a mean that's greater than 10, but not quite enough evidence. Perhaps we should just pull a larger sample.